cosine theta, and then I'll have d theta off to the side. So don't forget the dx. Because could you imagine getting through all of it and then you forgot the dx? You'd probably cry. I would cry. Okay.
Next to the dx is supposed to be.
Yep. I just put off over there. Sorry, my d thetas get a little janky. All right, so then we've got, wait, where I got to put this back in. So 2 sine theta, and this is all raised to the 3/2. That's going to be fun. We'll be fine. We'll be fine. Okay. So now we're going ham. We're squaring the stuff, dividing stuff. Okay. We're going to look for an identity. You might be able to see it, start seeing it a little bit. Okay, because with the squaring, you'll have 2 4s. Okay. So now is just like the hardcore simplifying piece of it. Oops. Actually, I'm gonna do the 2 and the 4 together and do 8. So I did the 2 and the 4 from the squaring, and then the 2 with the cosine for the 8. Okay. And then this, but see, stuff's disappearing. What is happening? Okay, there we go. And then what I'm going to do is, I'll just square that as one step. I don't want to, it's making me nervous. 4 minus 4 sine squared theta to the 3/2. That's going to be gross. We'll be fine. Now here's the thing. You can factor a 4 out, right? Just like the other time, you know? So it's going to be 4 times 1 minus sine squared. Okay. And then this is the part where you can be like, oh, hey. Do you know what I mean? And you can take 4 to the 3/2 now. So 4 to the 3/2 is what? Square root cube. So 2, 8. Oh, 8. Ha. Yes. You know, small victories, people. Small victories. So I'm going to do the 8. But I still have that 1 minus sine squared to this 3/2 business. So 1 minus sine squared is cosine squared. And that's your Pythagorean identity, like way above. Okay. So next, I have to get that 3/2 out of there. I'm going to get rid of the 8s. Well, the 2's cancel. Hey? So it's cosine cubed, right? Oops, d theta. Oops, I dropped d theta over there. Okay. We're going. Sine squared over cosine squared d theta. Am I supposed to know this, right? You know? Okay. And then you're like, it's tangent. And you're like, aren't I supposed to know this? You don't. I'm sorry. I'm sorry. Yep. Because you know the antiderivative of that guy. Not tangent. So you're going to use an identity again and do secant squared minus 1. Whoofda. Because the derivative of tangent is secant squared, isn't it? Right? So the antiderivative of secant squared is just straight up tangent. Thank the Lord. And then minus theta plus c. And then you feel circle, done. Just kidding. We're not in x's yet, remember? So this is our triangle business. So remember back in the day when x was 2 sine theta, you're going to do a little woo triangle. Divide out the 2. Sine is opposite over hypotenuse. And of course I need tangent. Silly. Why would I just use sine? So, of course, I gotta figure out adjacent, which is a little Pythag action again. Okay, so for the Pythag action, we're going to do x squared plus b squared, I guess, equals 2 squared. So I get b squared equals 4 minus x squared. Oh my gosh, so full circle, right? 4 minus x squared, remember? So b is the square root of 4 minus x squared, so that's this thing. It's wild. Okay. All right, so tangent is opposite adjacent. Cool. Minus theta. What? Theta? Oh, wait. Can't I just solve for it? I know, it's just like, just do a little inverse sine. That's how you get theta alone, right? I know. It's good times. Plus c. Yay. That's hard. There you go.